All right, in this video, I'm going to go over some of the Chapter 7 problems. So for this first problem, we're going to list out all the different ways to rent a cruise, right? So you have 2 destinations to pick from, 2 types of rooms, and 3 types of excursions. And so the easiest way to do this, and I think they want it. Let's see. I'm just going to type in here. All right, so I must want it in parentheses. Maybe this one all together, so let's try this. So what I would do is start with the first one. So turn my caps lock on. So we have the first destination, and then we can have a balcony, and we could do water sports, or we can do the destination inside view. And I'm sorry, I'm gonna stick with all the balconies first. Balcony and horseback riding, and then we could do Cosmo, balcony, and parasailing. Then I can switch it up and do inside view and list all those. Oops, I list all those again. And then that should be all the choices for that destination. Now we can start on Jamaica. So Jamaica, balcony, water. Oop. Jamaican balcony horse. Jamaica balcony parasailing. Jamaica inside water. Jamaica inside horse. Jamaica inside parasailing. Ooh, I'm missing one. Unless I don't like how I typed it. I don't think it. I just want to see. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Back to my answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why don't they like CBW, CBH, CBP, CIW, CIH? CIP. Did I miss one? I wrote water twice. Well, you get the gist. I get mine wrong because I wasn't paying attention. So make sure you don't. I see I got water written twice. So we're going to leave it in the video. See, we all make mistakes. So next. Remember, this is the thing in your calculator I showed you how to do. You can either use the factorial key, and just look at our formula. So if we go back to our notes, go to counting. This is the permutation formula. The combination formula, because see, it has a one outside the parentheses. So then you just go to your calculator and use your combination key, where it looks to be 12 and 15. Right, so you put that one in. E be the event where the sum of 2 dice rolled is less than 6. List the outcomes in E complement, right? So what are all of our, let's see if I can try to draw here. All right, so we get event E. It'll be the event where the sum of 2 rolled dice is less than 6, right? So actually, I save me some time. I'll go back to my OneNote here. Annotate. Get rid of my drawing here. We'll bring up both screens because it'll be a little easier to see. So sum less than 6. So here, again, we did this in class. So here's all of our sums. So our complement I gotta list all the outcomes that are greater than 6. So let's see, they want curly brackets. Nope. Maybe they just want the numbers. So 7. No, less than 6. So the complement would be 6 or more. So 6, 7, 8, 9, 10, 11, and 12. And again, I'm pulling these numbers from our in class. If you want more information on how we got these numbers, then go back and watch the Zoom lecture from class. Okay, so for this one, remember our R's formula. So we work our OneNote. We have that under 7.1. So odds of the event is probably the event occurring over its complement and not occurring. So this becomes 0.96 over 0.04, right? Because the complement, to find a complement, you do 1 minus. So 1 minus 0.96 is 0.04. So my calculator, I'm going to reduce this down, which is just becomes 24 over 1. And so when we put this in as a answer, then we put the 24 colon 1. So again, the formula is in my OneNotes. Next. Remember to find expected value. We multiply all of these. So my calculator do 1 times, 2 times 0.343, 4, 5, add them all up, and that is the expected value. That is the same as the population mean. That's out of 7.5, right? So you just put that into a calculator or open it into Excel. So 0.34 times 1 plus 2 times 0.34 plus 3 times 0.05 plus 4 times 0.2 plus 5 times 0.07. It's 2.32. Remember, we don't round. So it's just, again, that's under 7.5 in the notes. Let's see, Jessica decides to schedule. Oh, so this is like kind of like our problem we did in class, right? So 9 sections. She must take each of the following classes. She must take each of the following classes, right? 16 for English, 9 for Spanish, 11 for bio, 14. Oh, okay, so it's 16 choose 1, 9 choose 1, 11 choose 1, 14 choose 1, which should be, because they're just choosing 1, is just multiplying all those numbers together. This is a combination problem. So 22176. So again, this is under counting, right? And you're picking, so we are doing the combinations because order doesn't matter what order they take it in, right? And you're not going to take more than one of the same class. So it's just of each one of these, choose one as a combination problem. Simple 400 adults found that they have blood pressure. However, 90 of these adults reported being able to change their diet. So it's X over total, right? This is a good one. Let me read this one again. A sample of 400 students found, 400 adults, sorry, 82 had high blood pressure. However, 98 of those study reported to be unwilling to change their diet. Oh, so it should be just 400 minus 98. It's 302. So that's how many people are willing to change their diet. And we're just going to divide that by the total of 400. So 0.755. Right? So I know I'm not writing a lot of things. I'm mostly talking here, but 98 are unwilling. So how many are willing? Well, you take 400, subtract 98, which gives you 302. That is our event. That is our success. And remember, probability is success over total. And I just put it into my calculator. Uh, 300 students in the kindergarten class, 30. Wow. If each kindergarten can have only one task, in how many ways can you teacher sign out the following task? Line leader, wipe down the tables, pass out paper. All right, so this is a permutation. You're picking out 1, 2, 3, 4 tasks out of it. So you're going to do the permutation one in your calculator. So that would be, how many students? 30. Use the permutation function in your calculator, and you're picking for the 4 tasks, 1, 2, 3, 4. And order matters here because of if you get picked first, you're the line leader. If you get picked second, you wipe down table. So order does matter. So it is a permutation problem. So this is 657720. So remember, that's the key with combination permutation. Ask yourself, if I change the order, do I get a new outcome? And in this case, the answer is yes. So here's another odds one. I'll let you do that one. 3 cards are drawn with replacement from a standard deck. Find the probably the first card will be a spade. The second card will be a black card. Ooh, that's one we can think. So 52 cards. Now we got to kind of remember our cards. So I'll talk about, actually, let's see, annotate. I'll put this in text. Right, so it's easy to see, just for people that haven't used cards. So find probably the first card will be a spade. So there's 13 spades in a deck of cards. The second card would be black. So there is half red, half black. So half of 52 is 26. So there's 26 black cards. And the third card will be a 5 of clubs. So there's only one 5. I'll just put it as a C, 5 club. All right, so now it doesn't state it, but I'm going to assume that it is not with, oh, I don't want to do that. Undo, there we go. So first we get a spade, right? So there's 13 out of 52. So my first card is going over 52. However, we have taken a card out. So now I only have 51 cards in my hand. And I've taken out a card, and again, I only have 50 cards in my hand. So this one's easy. He's done. He's 1 over 50. 13 over 52 is done. Now, what's tricky here is clubs are black. So this card cannot be here. So I have to drop him down to 25 for my club card. And then also because I've picked a spade, I've also lost another card. So this actually becomes a 24. So 13 divided by 52, and they're then multiplying these together because they're independent, times 1 divided by 50, and I get a very small number. .0.00235 expressed in the millionth. So 10th, 100th, 1000th, 10,000th, 100,000th. So after my 5, I have 2 and then a 9. So that rounds up to 3. Ooh, am I right here in my decimals? 10th, 100th, 1000th, 10,000, 100,000, millionth. Now what's 0.002353? Let's see. I wasn't supposed to take out those cards. I don't agree with this answer. Unless, oh, I do agree with this answer. Make sure we read carefully. So I'll leave this in so you can see my mistake. It was with replacement. The card would put back in. The way I did it was without replacement. I assumed we were keeping the card. So make sure you read the problem carefully. So these numbers don't drop down. They stay the same. I got to read slower. So my answer that I got, which is not too far off, but it is because I changed my numbers. And again, I want to leave this in the video so you can see it both ways. Here is the solution with replacement. It means you drew the card, you put it back in. I was looking at it as you were dealt 3 cards and what was the order they were dealt in that way. So my solution is that you get dealt 3 cards and you keep your cards just as you get dealt a card and put it back into the deck. So again, probability, you got to pay attention to the wording. So that's good. We'll leave that in there. So back to practice. Next. All right, using the following table, find the following: randomly chosen member of the state government board is a sophomore or lives in campus housing. So sophomore are those two. Or lives in off-post campus housing, which is all of these numbers. So everything I circled is my success. And again, you divide it by your total. All right, now if this was and would be much easier. If this was an and, then my answer would just be 1 over the total, right? So we got to add up all these numbers to get your total, and then add up the numbers circled to get your or. So 8, so this is this way, 6. So 8, 10, 11, 15, looks like 19 is my total. And then 3, 2, 4, 6, 10, 11, 13 over 19. Oh, it says a decimal. So 0.68421, 10th, 100th, 1000th, 10,000th, 100,000th, 1. All right, so here's another table problem, right? So figure out what your successor total is for this problem. This is much like the card one, right? So list this out. There's 243 songs. There's about the first song played is a hip hop song, right? So hip hop, success over total. Here's one to do expected value of your winnings, right? So you need to borrow all right, so this is the one I want to use Excel to help with. So you got 2 different games you can play. So you got your sister and your mom, right? So give us some more space so I can build a table. Mom, right? Because remember, we're doing expected value, so we're going to create our different possible outcomes. So your mother says she wants you to roll a 6-sided dice. So the outcomes are 1, 2, 3, 4, 5, and 6. And she will pay you, she'll give you 4 times the number that appears on the die. So this is going to equal this times $4. So there are your outcomes. And you have a 1 out of 6 chance of winning each one of these. So this is equal to this times 1 over 6. And then we add these up. Oh, lost my sum because I'm in small mode here. Auto sum, there we go. So $14 is your expected winnings, right? Because remember, expected value is the event times its probability added together. So your sister, let's see what's her game. Before giving you money, so we play a game. Your sister says she wants you to spin a spinner with 2 outcomes, blue and red, right? And she'll give you $4 if spin it. So here's blue, red, blue. She gives you 4. Blue, and 16 if you land on red, because there is just 2 options. They're 50-50. So I'm just going to equals this times 0.5, and then the next one times 0.5, and then add them together. Well, 2 and 8 is 10. So your sister's expected win is 10. Mom's is 14. So mom has a better offer. All right. So Excel can help build a table. You don't have to use Excel, but you can help to build your table. Remember, again, move this out of our way. We're here at this expected value where we create this table, and it's X times P of X. We've already done the dice one, so you have that note. Here's another table to pick from. Without replacement, okay, there's 10, 1 through 10 in a bucket, was probably reaching the bucket and randomly drawing 3 balls numbered 4, 7, 3 without putting them back in. So this is like the card one where you count down. Here is another committee. So this is kind of looks like to be a permutations problem, and then another table, another table. Now, this is just like how many ways we can put people sit in the front of the class, and then finally another expected value. So a lot of repeats, kind of the same concepts, playing around how to do these. Hopefully this video is useful. I don't want to do all of them like I've been doing, so I want you to think through some of these as well. Again, we can kind of do like I have my notes on one screen, this, and then Excel is always a good tool. Email me if you have any questions.